Hi, my name is Mark Ryan, and this video is the second in a series of videos about my book, Deep Learning with Structured Data from Manning Publications. In this video, I'll describe some of the technology that's used to create the deep learning model described in the book. The book describes a deep learning system that predicts delays in Toronto's streetcar network. If you're familiar with Toronto, you'll recognize this picture. It's a map of the center of the city overlaid with a heat map of streetcar delays. The brighter the color, the more delays in that area. This map also shows the outline of the streetcar network. Can you see the St. Clair line? What about Long Branch? This visualization is one of the many techniques that's described in the book. This diagram describes the entire technology stack that makes up the solution described in the book. This solution predicts streetcar delays. On the left, there's a Python notebook that takes in the raw dataset and produces as output a cleaned up dataset saved as a pickle file. This pickle file is fed into another Python notebook that takes advantage of scikit-learn libraries and Keras to generate pipelines and a trained deep learning model. These are fed into the deployments on the right. First, the web deployment. This takes advantage of Flask, a Python web serving library, HTML, and JavaScript. On the bottom right is the Facebook Messenger deployment, which takes advantage of the Rasa chatbot framework, ngrok, and Facebook Messenger. And on the extreme right, you see the result. The trained deep learning model served in a web application or a Facebook Messenger app. One of the key concepts in the book is building up a deep learning model based on the types of the columns in the original dataset. Here, you see a snippet of the original dataset organized by column type. There are categorical columns that have a set number of values in them, continuous columns that contain numeric values, and text columns that contain free-form text. This diagram shows how the column categorizations are used to define the layers that make up the deep learning model. Continuous columns are sent straight through to a concatenate layer in the Keras model. Categorical columns have embedding, batch normalization, flatten, and dropout layers as well, while text columns have embedding, batch normalization, GRU, and dropout layers. In addition to showing you how you can prepare, train, and deploy a deep learning model, the book also contains a number of tips on using Python efficiently. For example, this diagram shows how you can take a Python object, save it in a pickle file, and then bring it back into another Python session. Pickle lets you use Python objects efficiently between Python sessions, and it's a great way to make your Python programming more efficient. And that's a brief introduction to my book, Deep Learning with Structured Data from Manning Publications.